Determine the magnitude of the electric force acting on the 1 coulomb charge. So there is 2 charges and 3 meters is the distance between them. And we are going to apply this equation. So 2 times 10 power 9 Newton is gonna be the answer. Two charges placed each hold the potential 3 coulombs and they have a potential difference both of 6 volts. The plate spacing D is 20 centimeter. A positive charge Q is 0.40 coulomb is located at the midpoint between the plates. Determine the magnitude of the electric field between the plates. Determine the capacitance of the plates. What's the electric potential energy of charge Q? So we are going to find the magnitude of electric field. So we are going to apply this equation for finding the answer of first question. So we can find 30 volts per meter. And secondly, we can use this equation for finding the answer of the second question. So we can find the capacitance of 0.50 Faraday. And we are going to apply this equation. So 1.2 joules is gonna be the answer of the third question. A sphere with a mass of 0.20 kg and a positive charge 0.10 coulomb is moving at a speed 10 meters per second in a x direction. The sphere enters a uniform 5 Tesla magnetic field that's directed into the page. What's the resulting motion? So you can find this. This is the velocity is going to be 10 meters per second and magnetic field is going to be 5 Tesla. And the right hand rule applies to positive charged particles and the charge will circle counterclockwise. So we are going to apply this. The charge will circle counterclockwise with a 4-meter radius. A rectangular loop of wire with length L, width W, and resistance R is moved into a magnetic field B at a constant velocity V. What's the magnitude of induced current in the loop as it enters the magnetic field? The induced EMF is caused by a change in a flux. The amount of flux will change as the loop moves with velocity through the magnetic field. So we can apply this equation. And the EMF gonna be this. So the EMF is essentially an induced voltage. To charge plates, each having a charge of 30 coulomb are separated by a distance of 10 centimeters. The plates have a potential difference of 6 volts. Determine the magnitude of the electric field between the plates. What's the capacitance of the charged plates? We are going to apply this equation. So the magnitude of the electric field between the plates is gonna be 60 volt per meter, and we are going to find the capacitance. And so we are going to apply this, and we can find 0.05 Faraday. A conducting sphere with a mass of 2 kg and a charge of 1 coulomb is initially at rest. Determine its speed after being accelerated through a 16-volt potential difference. So we are going to apply this equation. So this is the question 6. So we are going to apply this equation. So The speed after being accelerated is going to be 8 meters per second. A 1.5 kilogram charge with a mass of 0.5 kilogram is initially at rest. It releases and travels the meter in a uniform 3 volt per meter electric field. How much work is done on the charge during the motion? What's the speed of the charge after traveling 2 meters? So the work is gonna be this. And this is equal to kinetic energy and potential energy. And we can find this equation. Because we are going to apply this equation also. So we can find 9 joules is gonna be the answer of the first question. And we are going to find the answer of the second question. So we are going to apply this equation. So the speed of the charge after traveling 2 meters is gonna be 6 meters per second. So the answer of the first question is gonna be 9 joules, and the second answer, the answer of the second question is gonna be 6 meters per second. The induced EMF in the loop at the diagram is so the induced EMF caused by a charge influx. Flux can be determined by the area of the loop multiplied by the magnetic field passing through the loop. The amount of flux will change as the loop is moved with velocity through the magnetic field. So the EMF is gonna be this. What's the velocity of a 1 kilogram sphere with a 3 coulomb charge that accelerates from rest through a 6 volt potential difference? So the charge is going to be this, and this is the voltage, and we are going to apply this equation. And we are also going to apply this equation. So So the velocity is gonna be 6 meters per second. An electron with a charge of 1.6 times 10 power minus 19 coulomb is moving 1.1 times 10 power 5 meter per second in the plus x direction. The electron enters a 2 Tesla uniform magnetic field that's oriented in the plus x direction. What are the magnitude and the direction of the force that acts on the electron at the instant when it enters the magnetic field? Determine the magnitude of the magnetic force on the moving charge is gonna be this equation. So the answer is gonna be 3.2 times 10 power minus 14 to plus y direction.